Hello viewers, welcome to today's lesson. In today's lesson, we're going to look at a particular topic under additional mathematics, and the topic is matrices. The plural form is matrices, but the singular form is matrix. Before we look at how matrices are solved, let's look at the definition of a matrix. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns, primarily used in mathematics, that is linear algebra, to solve systems of equations. Some practical examples include students' seating arrangements, how students are being arranged in a classroom setting for lessons to take place. 2. Arrangement of the tins of milk in a carton, how the tins of milk are being arranged in a carton. These are some of the practical examples. Having gotten or obtained the definition of a matrix and some practical examples, let's look at matrix notation. Matrix notation is all about how matrices are written. Before you can correctly write a matrix, the following should be noted. 1. Matrices are represented by capital or block letters. Example, you can have an example as matrix A, matrix B, matrix Q, matrix M, etc. Numbers or symbols of matrices are written in rows and columns. As it was seen in the definition, the numbers and symbols, or the numbers or symbols of matrices, are written in rows and columns. Now let's use this example to explain this statement well. In matrix A, we have numbers 2, 3, 1, 4. Before you can know your rows and your columns, this one has to be linked with your verticals and your horizontals. Now, when we talk about the verticals, what are they? Horizontals, what are they? Now, let's quickly look at this. In this direction, upward, they are the verticals. And in this direction, that is in this direction, they are our horizontals. So we have our horizontals, we have our verticals. So when we pick this one is one of the horizontals. This one is one of the horizontals. When we pick this one is one of the verticals, another vertical. Now, all the horizontals are called rows. All the horizontals are called rows. So there is a row here, one row. There is another row here. Now, all the verticals are called columns. All the verticals are called columns. So we have this and that as columns. So we have column 1, column 2. So in the first column we have 2, 1. In the second column we have 3, 4. In the first row we have 2, 3. In the second row we have 1, 4. Thirdly, each number or symbol is called an element or an entry. So when we pick 2, 2 can be termed an element. 3 is also an element or an entry. 1 is also an element, and then 4 being an element or an entry. Now let's look at how matrices are described. Descriptions of matrices. That is the order or dimensions of matrices. The order of a matrix is written as number of rows by number of columns. Actually, it is number of rows and number of columns. So the and has been represented by the multiplication sign. So number of rows by number of columns. That is R by C, rows by columns. Now let's take this example to further explain this statement. Now let's look at this. Let's use this example to explain the number of rows and the number of columns. Now we've seen already from the previous subtopic that rows are for the horizontals and then columns are for the verticals. So let's quickly look at the number of columns, the number of rows we have here, so that we'll be able to know the order or dimensions of such a matrix. Let's begin by identifying our rows. So this is one of our horizontals. So one row, the whole of this is a row. The whole of this is a row. So going through, we've seen that we have two rows. And then when we take our columns, we have the first column, column 1, column 2, column 3. So we have 3 columns here, 3 columns. So by what we've seen, we can say that this one is a 2 by 3 matrix. 2 by 3 matrix. Number of rows by number of columns. 2 rows, 3 columns. So we have 2 by 3 matrix.